Hi, welcome to another video. In case you haven't joined me before, my name is Dennis Beatty, and I'm going to be teaching you a little bit more about Elixir. Specifically today, we're going to be talking about how to use Elixir's IO.ANSI module to write really cool command line interfaces. So first off, I'd really like to thank everyone who watched the last video, specifically everyone who gave me feedback on it. I got a lot of great feedback and I'm trying to implement that today. You'll notice I have kind of a new microphone setup that hopefully is going to improve our audio quality a little bit. And I'm doing something totally different by showing my face instead of just showing my screen the entire time. You'll also notice once I start coding, I have kind of a different setup so that you'll be able to see my face, but you can also see, oh, I got to get my pointing down, but you can also see my code is going to be a lot bigger. So it's going to fill your screen a little easier, and so it'll be a little better experience if you're watching on a mobile device instead of on your computer. Um, but I guess let's go ahead and get started. Last time we talked a little bit about IO.write and specifically how you can use IO.write with carriage returns to move your cursor to the beginning of the line and write over what you've already written in the terminal. And really the magic driving force behind that is that carriage return character, that slash R that once put into a string that's output to the terminal will move your cursor back to the beginning of the line. And that's kind of based on kind of old typewriters, how you used to have to type, and when you got to the end of the line, you would have to return your carriage to the front to begin typing at the front of the next line. And so there's a lot of these kind of escape characters that about 50 years ago were made a standard for controlling terminals and command line interfaces. And so if you're a little more interested in understanding kind of the history behind that, I'm going to link right here to kind of a crash course on keyboards and command line interfaces that kind of goes over that history a little bit. But otherwise, we'll go ahead and dive in. We're going to talk today about ANSI escape sequences. So these are similar to carriage returns in that they could control your cursor and move it to the front of the line, but they can do a lot more than that too. Like I said, they were implemented about 50 years ago as a standard, um, and they're a little more complicated to remember and type. So just kind of as an example, one of these might just look like kind of a special Unicode character, um, and then so it's really kind of a weird code, and so it's kind of hard to remember that. And so Elixir has a built-in library called IO.ANSI that will allow you to use those codes without having to actually remember the codes. So I guess one of the most common use cases for those is to use them for changing the color of your terminal. So let's go ahead and start out with some examples that do just that. So you've probably noticed in when you run your XUnit tests in Elixir, it outputs a line of green dots, and those green dots are made green using ANSI escape sequences. But then you'll also notice when you get errors, it prints those out in red. So you'll get your exception and your stack trace printed out in red text, and that's also ANSI. So we're going to kind of replicate a little bit of that functionality. So to start out with, let's go ahead and create a new file. And so I'm just going to call it color.ex. So inside of that, we'll create a new module, call that color. And then let's start with the color green. So we're going to make a function called green. And so this will just let you pass in some text, and it will return it with the code around it to color it green. So we'll say io.ansi.green, and then concatenate that with our text. And then at the bottom, let's say io.puts color.green, and then this text is green. And remember, you have to use io.puts or io.write. You have to actually output this text because io.ansi is really just a string that's getting appended to our text. And so we're just returning a string here. And so we need to actually display that string. So let's go ahead and run this. Color.ex. And so our text turned green. But you'll also notice that this turned green as well. So if I type anything else, it's also in green. So what we want to do is reset that. So I'm just going to add io.ansi.reset. And that tells our terminal, okay, so put out this text in green, and then we want to reset to the terminal's default colors for anything that comes after that. So we'll go ahead and give this a shot. Whoops, wrong command. There we go. And so you'll notice it turned green, and now we're back to our default. So we can do this with, there are 8 basic colors that have these functions. So we'll have red, um, black, green, yellow, blue, magenta, cyan, and white. So just for kicks, let's implement a second one that's red. We'll say io.ansi.red in our text, and then io.ansi.reset. And then let's go ahead and copy this, and we'll just change our greens to red. Okay, and let's go ahead and run that. And we'll see, okay, we have our green, and we have our red, and then we're resetting. So this is great for those 8 different colors. Um, you can also try out different modifiers. So they have like a light red, light green, light blue, and that makes your colors a little bit, well, it makes your text a little bit bolder to make it light. And then you can also use backgrounds. So it'll say io.ansi.red background or .green background or .blue background, and that will change the color behind your text. So instead of having red text on black, you could have black text on red. And so it's almost like a highlighter feature. But you can also do some really cool stuff that we'll get into a little later in this video. But basically, I highly recommend checking out the meta programming that implements these in the io.ansi source code. I'll go ahead and link to that up above me here. And um, it's just this really cool meta programming. It's a really cool implementation. And so I highly recommend checking that out. But basically, most advanced terminals support up to 256 colors. Um, the basic ones will support at least those 8, but then a more advanced one can do up to 256. And so that'd be a lot of colors to have a function for each one of those. So this is implemented using io.ansi.code. So let's go ahead and give that a shot. So we'll create a new function called color, or sorry, we'll call it code. And that'll take our text, and then we will use io.ansi.color and then pass in a code. So we need a code as well. And so that code is going to be a number between 0 and 255, and it specifies the color number. So then we'll take our text, well, so we'll append our text, and then we'll append a reset. And so in order to show you kind of all the different possibilities, I'm going to go ahead and delete this, and we'll use an enum.each to iterate over a range from 0 to 255, and then we'll pass in to our function that code. So then we'll say io.puts color.code, then our code, and then let's just say code and then the code. So basically this will just loop over each of those colors and print it out into the terminal. But in order to make that so that we can actually see it instead of just printing it all out at once, let's go ahead and add a process.sleep, and let's just say 10 milliseconds. That should be plenty. Okay, so now that we have that, I'm going to clear the terminal, and then we'll go ahead and run this again and watch what happens. So you'll see we're printing out all these different colors. So starting with our basic 8, so like I said, we have our black, red, green, yellow, blue, magenta, and cyan, and white. And those are kind of the basic 8 colors. And those are the first numbers in that 255 scale. And then after that, we have more advanced colors. And so really, you can use almost any of these in creating a really cool command line interface. So we'll come back to that in a little bit. But you can also use io.ansi's color background function to set a background color using any of those 255 or sorry, 256. If you don't want to have to write this code to see those colors all the time, I'm also going to link above to a graphic that will basically shows the colors along with the code for each one, so that you can use that if you're trying to pick out colors for a project in the future. So let's move on to another example. I I was looking the other day. I really love Docker and Docker Compose, And Docker Compose, if you've ever used it with more than one app, basically it starts up all the different apps in parallel. So it displays all the different apps that are starting up, and then after those have started, then it displays the word done in green next to the line that is up. And so those can be in different orders. And so basically we're having to move the cursor to the proper line in order to update those. And so I want to go ahead and try and replicate that functionality with you today. So let's start out by creating a new Docker file. So, well, sorry, not a Docker file, but a new file called docker.ex. So I'm gonna go ahead and do that. We're done with our colors, so I'm gonna go ahead and close that one. And then inside of our docker.ex file, I'm just gonna say def module docker. And then in order to keep kind of the same standard from Docker Compose, I will just call this function up. And then basically, I'm just going to replicate exactly what Docker Compose does. So it creates a network. I've been messing around with this graph database called dgraph. Also really interesting. I highly recommend checking that out. But basically, it spins up 3 different apps. So say creating, and then do this. So we'll have our 3 different ones. And then one is called dgraph 0. And then another is called dgraph server. And then they actually line up all these ellipses. I'm going to go ahead and do that, just to kind of keep that. And then dgraph, I'm not 100% sure, but I think this is ratel, or rate 1, I mean. I'm not 100% sure exactly what that does, but basically dgraph creates it, so I'm going to go ahead and include it. And so then we'll just call docker.up at the end. And so right now, this isn't going to do anything too special. It's just going to print out exactly what we told it to. But what we're going to do is we're going to print out the word done on the end of each of these when they're done spinning up. So to make it obvious that we're updating after the fact, we'll also use kind of a process sleep and try and update them in a different order. So to start out with, let's go ahead and add a module attribute here. So I'm going to call this done text. And we'll just use io.ansi.green, and then the text done, and then io.ansi.reset afterward. So that way we can change that easily, and it's specified up at the top of our file. So now let's add a line done function, and this will take in a line number. So which one of these 3 lines is being updated. And we're making it a private function since we shouldn't be able to call that outside of our Docker module. And then, so we'll start out by calculating an offset. So when we're over here, our cursor comes down after we've put out each of these lines, comes down to the next line. And so basically, we need to figure out how many lines up we need to move it. So starting here, we're at 0. So if we're calling this line 1, we need to figure out to get from here to line 1 will take us 1, 2, 3 lines up that we need to move. And so let's use 4 minus that 1, and that should give us the right offset. So line 2 would be 2, because 4 minus 2 is 2, and then 4 minus 3 is 1. So that should be what we're looking for. So I'm going to say offset equals 4 minus the line number. And then let's go ahead and say io.ansi.cursor up, and then by that offset. And so that should move our cursor up to the proper line. But then we need to move our cursor over to the right. So if we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. We need to move it over 30 characters. So we'll be adding io.ansi.cursor to the right by 30. And then we're going to need to output our done text. So you'll notice that right now I'm not putting these into a string. Let's go ahead and do that. So we'll have our offset, and then I'm gonna go ahead and pipe that into our cursor up function, and so then we have a string. Well, I'm gonna pipe that into our kernel dot and then our concat method, and so that will concatenate this string with this one. And so this lets us use a pipeline to kind of continue to build this string. Now, if you're doing this a lot, this isn't going to be great. This concatenate isn't great for performance reasons. I'll let you go learn a little bit more about that if you're interested. But for these small examples, this should work fine. I'd also recommend looking into IO lists. I'll probably do a quick video about those at some point, but basically they allow you to have even better performance when you're outputting to your terminal a lot. But basically, returning to where we were, so we moved our cursor up to the correct line, and then we moved it over to where it needs to be. So then let's go ahead and write our done text. And then let's say, okay, now we need to move our cursor back to where it needs to be. So I'm just going to say io.ansi.cursor down, and then by that same offset. And then we want to move our cursor back to the front of the line. So let's just add a carriage return like we did last time. And then finally, we need to actually write that out. And so this should do exactly what we're looking for. It'll move to the right line, it'll put the text, and then it'll move itself back, so that then we can more easily calculate where it needs to go next. So we actually want to hook this in to our current code. So let's go ahead and make this a little bit interesting by randomizing the order that these start in. So I'm going to create a range from 1 to 3, and then I'm going to use enum.shuffle, which is going to basically take that list or that range and move all of those numbers into a random order. And then we'll say enum.each and call our line down function, and pass in that line number. So then that should do exactly what we're looking for. So let's go ahead and run that and see if I'm right. So you'll see, oh, function line done is unused. Oh, I accidentally called line down. My bad. So let's go ahead and clear our terminal, and then we'll run it again. And you'll notice that those happened right away. So let's go ahead and add that process.sleep. And I'm going to do a half a second. So that should give us some time so that we can actually see those come in. And let's try that again. There we go. So you'll see this last one came in first, and then this first one, and then the second one. And now if I do it again, it's going to be probably in a different order because it's getting shuffled. I think that was actually the same order. There we go. That one was in kind of the straight order. So basically, what we've been able to do was kind of write to each of those lines by moving our cursor around. But if you want a follow-up exercise, I'd actually recommend trying to randomize the finish state of each app, so that it can be either a green done or it could be a red error. You could also try making the app list dynamic so that even with like 12 lines, you're still writing the status on the proper line. And maybe even making it so that they can have a dynamic length as well, so that 30 is not hard-coded. There's a lot of things that you can do with this. I'd highly recommend continuing to play with it. But the final example that I want to cover today is going to be covering the terminal. Basically, IO.ANSI has a nifty function called cover that lets you cover the entire terminal window with the current background color. So let's make kind of a UI that we'll call it a downloader. It's not going to have any like functionality or anything. But basically it will cover the window, and then it will print a text box in the middle of it, so that instead of typing in the bottom left corner, you're typing this text box. Just kind of as a fun little exercise. So let's go ahead and start by creating, I'll just call it downloader.ex. whoops, sorry, I wasn't sharing my screen. Just opened this new downloader.ex, and then I'm going to say def module, downloader. Okay, and then let's just give it a function called get file name, because that's what our text box will do. So get file name. We shouldn't need any arguments there. And so let's start out by just covering the screen in the desired background color. So I'm going to create another function called draw background. And with that, I'll just do io.write, io.ANSI.color background. And then I found this I really like this nice purple color, and it's color code 53. So we'll use that color, and then we'll use io.ANSI.clear. So we're setting that background color, and then we're clearing the screen and leaving just that background. So, and then we want to actually call that function, and then call our main function down here. So we'll say downloader.getFileName. Okay, so let's go ahead and run this. Elixir downloader.ex. So you'll see we covered our screen in purple, but it's still covered in purple even though our program has ended. And so to take care of that, let's add a new function called reset. They'll actually reset the ANSI settings and clear the screen at the end. So I'm going to go ahead and do that. Let's def p reset, and then that will say io.write, io.ansi.reset, io.ansi.clear. So this will put our background color back to normal, and then it will clear the screen. And then let's add that up here. And so now, if we try running it, you'll see now we have nothing at all. And that's because our program ran, it changed the background color to purple, and then it changed it back and cleared it, but it did it so fast that we weren't actually able to see it. So let's go ahead and print out our label and input, and then we'll use io.read to wait for the user to enter a file name, and that way it'll stay on the screen until we're done. So in our get file name, let's call a function called draw input, and this will actually draw the input box that the user will be able to type into. So we'll just put that right here, say def p draw input, and so we'll say we'll put out io.ansi.color, and so this is going to be the label above our input. And so I'm going to create a new module attribute. We'll call it label color. And then let's also make a module attribute for our label text so that we can easily change those too. So if we say label color, and so I'm going to make our label color 15, and then our label text, I'll just call it file name. So then after our label, then we'll say io.write, io.ansi.color background with our input color, and then we'll actually draw our input box. So I'm going to make a separate function for that. So basically, if you remember how we did the progress bar in the last video, we're going to do kind of that same thing for the input box. We'll use string.duplicate to just duplicate a space to the input size that we specify. So we'll say at input size, I'll just say 20. So that should create us a simple input box using the color that we specify for our input color, which I forgot to add. So I really like this 183. So I'll show you all these colors in a second when we run this. So we've created our input box, And then drawing our input, let's finally add a carriage return so that we're moving our cursor back to the front of that input box. And then we're going to want to change our text color inside of that input. So let's add an input text color, and we'll call that 53. So we're using the same as our background color, just on this new, on top of this new background, so that it'll show up. So now we've drawn our input. Now we're going to want to actually get the file name. So if we say file name equals io.read, and then we want the whole line. So basically, what this does is it says, let's wait for the user to actually input some text and hit enter. And once they hit enter, then we'll read it. And so it waits on the user. And so this will leave that input there until the user presses enter. And then we'll reset our screen, and then we'll return our file name. So this should actually get the file name that they enter. So I'm just going to throw an IO.inspect onto the end here, and we'll say, we'll label it with the file name, so it will tell us what that file name is that they've entered. So let's go ahead and give this a try. We just say Elixir downloader.ex. So you'll see it covers our screen in that purple, and then it displays our label as well as this input box. And so when I type right here, it types in the same purple as our background color. And when I hit enter, then it gets rid of everything and just has our file name is equal to dennisbeatty.com, and then you'll see it has this new line at the end because I pressed enter. So whenever you use whenever you read a line, it's going to have that new line at the end. And so we really don't want that there. So let's go ahead and change the returning line of our get file name function to remove that. So if we just say, instead of file name, we can say string.trim file name, and string.trim will remove any white space. So from the ends. So at the beginning or the end, if there are any spaces or if there are any new lines, it'll get rid of those. And so the other thing you might notice is that when we ran this, so I'll go ahead and run it again. When we run this, this input is at the top left of the screen. And so I think we can make this a lot cooler if we move it so that it's centered in our terminal. And IO.ANSI actually makes it so, I mean, like we saw, it's simple to position our cursor and write somewhere else on the screen. But the problem is that it isn't easy for us to know the size of our terminal. Erlang has in its IO library, there's an IO rows function, as well as an IO columns function that are supposed to help with this. And if you try running them in IEX, it'll give you the number of rows and columns that your terminal has. And so I tried to create a program to kind of work with that, but I noticed that it actually gives an error when we do it in the way that I've been showing you in this video. And that's because apparently it doesn't recognize that as a terminal device. And so after spending a lot of time trying to find a workaround, I decided that we'll just use kind of a basic Unix, it's just a basic Unix program called tput. And that lets you run tput calls or tput rows, or sorry, tput lines, not rows. And that will give you the number of columns and number of rows in the terminal. And Elixir has a really simple way of actually calling out to other functions, just using system.command. And it takes a command and a list of arguments and then returns the exit status code and the output of that function or of that program. But if you know any better way of getting the terminal size in a program like this, please reach out and let me know. I'll happily update this post. I probably won't update the video, but if you check in the links below, there will be a link to the blog post, and I'll put any updates there if I find one. But otherwise, let's go ahead and use system.command and tput, and so we'll go back to that. So go ahead and go over to our code. So I'm going to create a new function. I'll just put it at the bottom, and I'll call it screen size. And so with that, we will return the number of lines and the number of columns. So I'm going to create a new function. I'll just call it num. We'll say lines, and then num calls. And so use num, and then subcommand. And so this will just be a thin wrapper around our system command. So we'll say case system.command tput, and then the arguments go into a list, and then we'll pass in our subcommand. And so basically, if this returns text and then an exit code of 0, then we will take the text and we'll trim that using that function we used before, and then we'll convert that to an integer so that it's not a string, because it would come in as a string from the system. But if for some reason we don't get that that tuple that we're expecting, let's just say 0, and so we'll default our input to be at the top left. So with this in place, we should be able to get our screen size now. So let's change our draw input function to actually use that screen size. So we'll grab rows and then columns equal to our screen size. And then, so we're going to do some fancy arithmetic here. Let's use float.floor around a function that takes the number of rows and divides by 2. So this will figure out how many rows are on our screen, and then it'll divide that by 2. But float.floor makes it so that just in case we have an odd number, it'll go to the line above that. And then we'll go ahead and truncate that, which makes it so that it will be an integer instead of a float. And that'll, because that's what IO.ANSI is expecting when it's moving the cursor around, is an integer. So then we'll do basically the same thing with the column. So we'll say float.floor. This one will get a little bit trickier. So we'll say columns and then minus our input size. And we'll do this because we want to print our input starting at the, basically we don't want to start printing right in the center of the screen. We want to do it offset enough so that our input will be centered. So we'll take our columns minus our input size and then divide that by 2. And then we'll truncate that. So this should tell us exactly which row and column we need to move our cursor to. So let's go ahead and move the cursor to that position. So we'll say io.right, io.ANSI.cursor, and we'll just pass in the row and column. And this is a handy convenience function that they have. So it will move the cursor to that exact spot. And then we'll add, then we want to display our label. So we'll say well, I'm just going to copy it from down here actually. So let's say this exact piece. And so after that, we're going to move the cursor down a line, but we don't want to move it back to the start. So I'm just going to say, well, let's use this exact same code right here. So we'll say io.ANSI.cursor, and then we'll say row plus 1 because we want to move it down a row, and then we want it to start in that same column. And then we have our background color and our input box just like before. And then we will write, after that, move our cursor back to that same position. So we don't want to do a full carriage return. So we'll just say io.ANSI.cursor row plus 1, and then column. And so that just moves it to the exact same position as we started at. And so that says, okay, put this in the front of the input box and then use our color so that we can start writing in that input box. So let's go ahead and run this. So downloader.ex. So now you'll notice right in the middle of our screen we have our file name label, and then we have our input right under that. So if I just type in a file name, then it's putting that out. There's just one remaining problem, and that's that this is printing about halfway down the screen. And that's because our cursor was over here to actually draw our input box into type. And so when we actually, when we hit enter, it moves our cursor down to this line, and then it prints it out. Well, what we need to do is we need to reset that. So let's, in our reset function that gets called at the end, it's called IO.ANSI.home. And let's try running it again. Voila. So that's right at the front, the top of our terminal. So we now have a module that covers the screen, displays an input, and then reads an input out of it. So yeah, if you want to keep going with this, you could try pulling in what we did with the progress bar in the last post. So you could try centering that on the screen and maybe adding some color to it as well. And maybe even making it download something. If you do, please reach out and let me know. I will link to my Twitter right here, as well as in the notes down below. Or if you're reading the blog post, that'll also be on there. So that's pretty much everything I want to cover in this video. And it looks like we're at about 37 minutes right now, so plenty long. Overall, ANSI escape codes allow you to do some really cool stuff with terminal output, and IO.ANSI is incredibly helpful in allowing you to work with that. There are some drawbacks though. If I go back to my screen and I scroll up, you'll notice that this is still here. And this is because I'm in iTerm. If I were doing this in a normal, like the Mac standard terminal, I would still have that entire purple screen in my terminal history. And so basically what ANSI is doing is every time we cover the screen, we're really just printing enough lines that all we see is the new background color. So it never truly goes away. We could hack something together using IO.write to write over each line with blank characters, but there's actually a better solution, and that's ncurses. Basically, ncurses allows you to build some really powerful command line applications and even games. Um, Jim Freeze, who organizes the Elixir conf, basically he created an Elixir wrapper around it that allows you to use it in your Elixir applications. And so I may write about a little bit more about that in a later post. But I'm also going to link to some really cool examples down below. Someone has made like a snake game or a Space Invaders style game using curses, and specifically that Elixir ncurses library. So basically, like last time, please let me know if you end up using this anywhere. Also, please let me know if you have any feedback on the format of this post or on the video. I especially want to know if there was something in the examples that you got lost on, if I was moving too fast, or if there's anything I can clarify, just so that I can do a better job of that in the future. You can find me on Twitter at DNSBTY, or on the Elixir Slack user group with the same name. Or you can just let me know in the comments of this video. I plan to keep releasing videos like that, so if you're interested, please like the video and subscribe to my channel, so that YouTube will let you know when they're coming out. I'm also adding a new mailing list. If you're on the blog, there should be a form to sign up for that at the very bottom. Otherwise, I'll link to that in the show notes. But if there's anything that I can do to help improve your experience with learning Elixir, please reach out and let me know. Thanks again for watching.